the video from section 1.6, we've already talked about complex numbers. I gave you a review on complex numbers. Remember that a complex number is in the form a plus bi, where a is the real part, and b, not the I, just the b, is my imaginary part. Alright, so let's just look and see what's going on here. Alright, so remember, if we've got a rectangular coordinate system, we know what that is. If I had a rectangular point, I would just graph my x-axis and my y-axis. Alright, this is very similar to how we graph a complex number, except this axis right here is going to be the real axis. And then this axis right here is going to be my imaginary axis. Alright, so if I were going to graph a plus bi, for example, so my real part is a, so I would go over to the left or right a, and then I would go up or down whatever my b value was. So let's just say this is a plus bi. Right? Alright, so if I look at this, if I look at the distance from the origin right there, this is what I'm talking about. So I would go over a, the real part, and up or down b, and then I would have my point, just like I did with x and y. Okay. Now let's look and see what this value would be. Remember that if we're talking about polar form, we're not talking about x or y, we're not talking about a or b, we're talking about r and theta. So let's just call this r, for example. Alright, so there's my r value, and there's my theta. Alright, well, what is r going to be? Well, look at this. This is a right triangle, and we know how to find this. This is just using the Pythagorean theorem, so I know that a squared plus b squared is going to equal r squared. So r is just going to equal the square root of a squared plus b squared. Alright, and we actually call this the modulus. Alright, so if I'm looking at an imaginary number, and you might see it written as z, so they're going to name the complex number z, and then they would say the modulus, which we're going to call r, is actually just the absolute value of z, right? It's the distance from the origin. Alright, so we'll call that the modulus. The other thing we need to know, so we've got r, we need to know what theta is. So theta, we know, if we're looking at in terms of my complex of a and b, well, I've got the opposite and the adjacent. So I know that the tangent of theta is going to equal b over a. Alright, so really this is all I need to know. And theta is actually called the argument. Alright, so if they ask for the modulus and the argument, this is what we're looking at. We're looking at the distance from the origin. That's just the square root of a squared plus b squared. Or we're looking for theta. Alright, and that's how we're going to find that. Now, to write a complex number in polar form, we're going to need this formula right here. So we know that we already know what the absolute value of z was. That is r. We know that what theta is. That is the tangent of theta is b over a. So going from a complex number to a polar number, we need the fact that z is going to equal r times the cosine of theta plus I times the sine of theta. Notice there's still an imaginary part, but now I've got r and theta going on. Alright, so let's do some problems with this. Alright, so 8.3, this particular exercise, number 10, is actually just to graph this, graph the complex number, and to find the modulus. Alright, so if I'm graphing this, I'm going to draw my real axis, and I'm going to draw my imaginary axis. My real part here is 7, so I'm going to go over 7. And my imaginary part is negative 3, so I'm going to go down 3, over 7, down 3, and so there's that point right there. Now, if I want to find the modulus, remember that that's that distance from the origin there. Alright, to find the modulus, I just do square root of a squared plus b squared, which in this case is going to be the square root of 49 plus 9, which is the square root of 58. Okay, so that's graph